Hello everyone, my name is Dante Madej, and I'm a junior from NSU University School. In this project, I created the cake canvas ProFrost, a functional prototype of a frosting 3D printer made by modifying a CNC machine, designing custom parts in CAD, and uploading custom control firmware. However, before I get started with that, I firstly want to discuss the backstory of this project and my reasoning for creating this, of all things. First, I want to get into my head for a second and ask yourself the question, what is chocolate? Other than a byproduct of one of the strangest looking seeds, chocolate is something that many people enjoy eating, meaning there's at least some connection that people have to a project revolved around this. However, as the more astute you might have noticed, chocolate already exists. I pondered what I can do that relates to chocolate, and the answer? Cookie cake. Once again, this does already exist, but picking this narrows down the selection of what I should do. I don't like regular cake, I know, but cookie cake is the one exception, even if it's barely classified as a cake. So, cookie cake was an obvious choice for a fun, cake-adjacent project for me. Now, if you've ever had fun before, you might know something that many people like to do with cakes. No, not eating them, but decorating them, as it's a socially acceptable way to play with food. It can be very fun to do with company, and it's satisfying to see designs come to life, which is why it ranks so high on the fun things to do list. But what if we could take the soul out of this craft and make a machine to decorate the cakes for us? In all seriousness, cake decorating can be very messy, and the designs are just a summation of your artistic talents, which means even stick figures would pose a legitimate challenge for me. By creating a machine that can print with frosting, I can perfect designs digitally first, or use designs by people far more talented than me before having the machine accurately replicate the design. This negates my bad artistic talents, while leaving me with a project that leaves me eating cookie cake, which I have no qualms with. In addition, because of convenient timing more than anything, I also integrated this project into a group project for school. Every year, in a semester-long project, students taking the economics class have to create a mock company with different chief officer roles being chosen to then attract investors, which are just parents and staff, to set up a company during an event called the trade fair. I was chief operating officer of my company, so I was responsible for making the actual product, and given that I was the only person working on it, I passed information about its limitations and finances to the other officers. Given that the cake canvas was now technically a school project, it did not have to be nearly as complex as it ended up being. In fact, a prototype wasn't even required. However, this project was going to be completed anyway, with or without the trade fair, but this just gave me both an excuse and a deadline to make this product a reality. So, how did I start? First, I knew I need some machine that can already move in a controlled manner, which left me to choose between a CNC machine and a 3D printer. It was a close call between the two, and choosing one or the other came down to how each is meant to be used and how easily I could corrupt them to my sick and twisted goals of cake decorating. First, let's take 3D printing, a type of additive manufacturing. Where there is nothing, you add something to create a manufactured part. Look here. At first, there is nothing, but soon enough, there is something, a complete part. It does this by melting plastic and placing it down where necessary. This would be the most similar to my project, as I would just have to replace the filament that gets melted into frosting, because plastic isn't edible.
Ice cream is the world's first food made from plastic.
Yet. On the other hand, a CNC machine works on subtractive manufacturing, where you take something, commonly wood, and subtract material until it becomes what you want. CNC machines work by spinning a spindle, which is a sharp blade revolving at a cool 12,000 RPM, and then using that blade to cut out material, and the places that haven't been turned to dust are the resultant parts. However, this powerful and speedy motor makes it difficult to adapt to more gentle applications like cake decorating. Though a 3D printer would be most similar to my project, I ended up getting a CNC machine to get the frame. Yippee! I chose this because a 3D printer would be way too tall. Cookie cakes are ridiculously thin, and frosting can't realistically print vertically, so the extra vertical height a 3D printer would get me would be useless and cost more. Now, this meant that I would have to find a way to get the CNC machine to reliably extrude frosting, but I decided that the cost of the CNC machine outweighed this, so that I could spend the saved money on an extrusion method for the frosting, one that I would have needed to implement on the 3D printer anyway. So to get started with this project, I bought a few large syringes, each 150 milliliters, which turned out to be totally overkill. This is a lot more volume than I think I ever needed, but it does help with reducing the amount of refills, and it fits nicely in the frame. Now, given the chocolate gold standard mindset that I heeded throughout the project, I bought some Betty Crocker chocolate frosting to use as my filament. There's also a few other reasons why I chose this frosting, like how regular frosting is just sad sugar water that makes me feel like a domesticated ant yearning for the outdoors. but it's also because the trade fair had us required to get food store-bought. It makes sense from a safety perspective, but it did mean that I had to adapt to a different type of frosting altogether, which came with some of its own problems. There's one more thing you should know about chocolate. Not only does it taste good, but it's deceivingly viscous. Just look at this clip of me absolutely struggling for dear life when I was testing it, and the thin nozzle at the end of the syringe isn't doing me any favors either. Now, instead of making the nozzle on the syringe larger to make it easier to push the frosting out, I decided to stick with this size as it would result in the machine making better designs overall. The thinner nozzle would let me do finer prints, and the frosting would not leak nearly as much, and therefore the individual lines could be thinner and the designs more detailed. Although it's much harder to print the frosting like this, I'm making the mother of all omelets here, Jack. I can't fret over every egg.
Making the mother of all omelets here, Jack. Can't fret over every egg.
So, with the starting components just sitting on the desk, I just need to get started. First, I assembled the CNC machine, and given the behemoth of a motor that came with it, I wondered if it could be used to extract the frosting without any other purchases. It would just be sitting there, so it was at least worth a shot. However, after a few tests of the speed, the motor was just way too fast, and unless I could create an insane gear reduction to slow it down, that idea was quickly shot down. Given this, I checked out an old motor that I had left over from some Arduino projects. Although weak and puny, after 3D printing a rack gear, I thought I would at least give it a try, and who knows, maybe we'd be able to extrude the frosting. The problem was that the motor had as much effort behind it as a gag gift from Spencer's, and the weak and puny motor was, shockingly, weak and puny. The motor couldn't move the piston even when it was just filled with air, so I knew trying to put frosting would be useless. Given the inadequacy of the motors I already had, I searched for a better motor online, still clinging to the rack gear attached to the piston idea. I searched for torque motors, and bought a motor with a whopping 1 RPM, a 12-volt synchronous motor. Now let me ask you this, do you know what a synchronous motor is? Neither did I, and foregoing the instructions, I'll give you an illustrating drawing of what happened, since unfortunately I wasn't recording anything at this time. If the CNC board hadn't just been fried, a part got so hot it melted a connection and bypassed the on-off switch. Even when powered off, the CNC motor that I used in place of a multimeter would try to run. Unplugging the board didn't make it safe either, as the capacitors were still very much charged, and I didn't want to risk getting electrocuted and getting blown into the stratosphere.
Really appreciate it.
Side note, this is why I wear black gloves in all the clips, just in case the ghosts of electrical safety hazards past come to haunt me. So, instead of replacing the CNC board exactly, trying again with the rack gear method, which would probably break under the torque anyway, I got a 3D printer board. It allowed me to use a stepper motor instead of a regular brushless DC motor. The difference between them stemming once again from how each machine is intended to manufacture. The subtractive CNC machine uses a powerful motor that gets turned on and off with some speed control in between. This works great for cutting wood, where super precise speeds and holding positions down just isn't necessary. It just has to spin fast. However, this new board uses a different type of motor, one that fits the needs of the 3D printer's manufacturing method, being very precise, albeit much slower. 3D printers use this motor to move filament at an exact rate to make sure the printed object has a consistent amount of material distributed throughout. This is the same type of motor that's used to control the position of the printhead on the CNC machine, just to put in perspective how precise these things are designed to be. The CNC board used 3 stepper motors, one for each axis, X, Y, and Z, and the additional DC motor to run the spindle, while the 3D printer board uses 4 stepper motors, one in order to extrude filament. Stepper motors work by using electrical currents to balance the motor's rotation, and changing the electromagnets causes the motor to move in steps, which means it can move in very precise, very small increments. With some modification to my design idea, I should be able to print the frosting just fine. After safely disposing of the other board, I needed to get the new board and mount it to the back of the machine. The screws that I was using before didn't fit, so I made some pins and fitted them onto the back of the board. After safely securing the board by never placing it back up there again unless completely necessary, I could now continue with the project. After unboxing it, I had a better suited motor to extrude the frosting. This time, I was willing to take any chances with a weak motor, since this one was an absolute beast, with 1.26 newtons per meter. This is an insane amount of torque, especially for something so precise. Now, there was one small issue with getting the board to work. I was so scared of electricity after frying the other board, I haven't given it a second thought since, but I still needed a way to power the machine with the new board. The whole frame and additional motors cannot simply run only from my computer when plugged in. So, being resourceful with the remaining CNC components, I thought about using the old cord that came with the CNC machine, since it already had a power supply brick built in. The specifications for voltage and amperage seemed to match the new board, but I needed to check if there was a wattage disparity, as that would determine if the power supply could have everything run simultaneously. Wattage is a measure of how much power can be provided, literally being the unit of power, and with power supplies is an upper bound of how much power that it can provide. As long as the wattage draw from the board and the sum of the components was less than what could be provided, the power supply should work fine. The new board didn't have any large wattage draw, so I went ahead with using the older power supply, but it wasn't a nice connector on the new board. It was rather 2 screws for power that I needed to screw in. I didn't want to strip the wires on the power supply since I only had one, so I got some compatible female barrel jack connectors and stripped the ends of those instead. I connected them and plugged it into the outlet to see if it would blow up.
So I'm going to plug it in. If it explodes, I'll be very sad. Okay, nothing's blown up. Which means I'm basically goated.
After it didn't, I started to move it back to make sure everything was still working.
Okay, this moves that, this moves that.
Now, I needed a way to get the big motor moving. I soldered wires onto the connectors so it would be easy to keep them on the board. After being threatened by the geese quite a few times, I had connectors that I could easily attach to the board. When I was trying to spin the motor, I was confused as to why it didn't spin. Reading the error logs, it said cold extrude error. This error is for regular 3D printers where nozzle can get damaged by trying to force unheated filament through it. However, I didn't have this limitation, so I disabled it by directly sending G-code commands to the new printer board. G-code is the language of numerical controllers like CNC machines and 3D printers, which tells the motor to go to certain positions along with other necessary controls like emergency stops. And after disabling this error, I was able to move the motor successfully, meaning I just had to get everything else built. Here's the current plan. I saw this video of a guy extruding clay, and I was going to take a very similar approach to printing the frosting. Clay is much thicker than frosting anyway, so it should be much easier. The rundown of his extrusion method was this: have a motor move a screw, which rotates a nut attached to a plunger, which is on rails. When the screw moves, the nut wants to spin with it, and with it wants to spin the plunger. However, given the plunger's rail prevent it from rotating, it will instead force the plunger into a linear motion. I was going to use the same principle for my project, but I need to first mount the screw onto the stepper motor. Now I, as a physics enjoyer, knew that in order to rotate the screw with the stepper motor, I needed to connect them.
You didn't have to cut me off. I could never know we were nothing.
The screw in the motor adapter wasn't made for such a large motor, and the inside was far too small. So, using some Cuban engineering, we drilled some holes into the adapter and quickly fixed that. Now, as you can see, it was still fairly wobbly and a little bit off center, but after some adjustment to the screws that was holding it up to the motor, it was only just wobbly. Given we removed a massive amount of internal material, the adapter was structurally much weaker and therefore springy. But I viewed that as a benefit, making elasticity a weak point instead of snapping some of the more delicate parts that I was going to make. Given I had the motor and screw completed, I now just needed a plunger that can fit with the nut. So, after attempting to replicate the top of the syringe in CAD, I printed it. This original model could not fit the rubber very well, and I was worried it would fall off each side of the plunger. So I redesigned it and printed it, so it fit well enough that I added it to the final design of the plunger. The plunger has a little notch at the end of it, so that it can catch onto the rails that I was going to make, as shown by the clay video. Now, I started printing the plunger, and the filament jammed. No worries, I can just restart the print. So I started printing the plunger again, and keep an open ear for this. Terrible. A transformer blew up, and the power went out when I was printing. It's not that big of a deal, I can resume it like this, but it was given position a little bit off, so it left a neat little scar on the plunger where I started printing marginally off center. Now, after I finished printing, I had a working plunger with a secure rubber seal that can move up and down without much resistance, and the plunger is secure enough to rotate on the screw. As you see on this clip now, it's currently really hard to get the syringe out, but but at the time it didn't have that much resistance. It was super smooth before, but for some reason on the 2 syringes that I tested with frosting, whenever they came in contact with defrosting, they shrunk up and became unusable. However, I recently got new ones, so I can finally print frosting again, and they are as smooth as butter. Now that I had the plunger, I just needed a way to mount these to the CNC machine with all the other components. I decided against using just one large part to house a syringe like the clay video did, and was instead going to use 2 parts, mainly because of the way that I would be attaching it. Firstly, I saw these 2 holes on the movable Z-axis of the print head, so I decided this is where I would mount the extrusion assembly, since it seems to be the most sturdy option, and retain all axis control. The 2 parts are as follows: a bottom bracket that would attach with these 2 holes, and then a plate on the top to hold the syringe, and then a top part altogether that would screw into it, which would house every other component, the screw, the motor, and everything else. So I started a rough draft of the idea, and made a few test prints to check my measurements. I'm a big believer in measure thrice, cut once, or in this case, print thrice, print again with the whole thing once. This mitigates wasted filament when printing something massive, as each component is proven to be working beforehand. Let me show you what I mean. This here is the first print for the motor size. The bed unfortunately wasn't leveled well, so it was just a thin broken sheet, but it had all the corners where I needed to confirm that the motor was accurate in CAD. After I confirmed I can safely attach the large stepper motor, I then designed the bottom part of the mount, starting with these small holes that I would then attach to the movable Z-axis of the CNC machine. That's what these rectangular slots are for, to use old components that came with the CNC machine, the screws that were meant to slide along the original extruded aluminum rails. After measuring each, the flaky test print tested the hold distances and another print that could hold the screws well, so I printed the full bottom mount. The supports ended up being not very helpful and added an extra hour of print time, so for the second version, I skipped them altogether. This version held the syringe and was sturdy enough to be used without worry. However, this would be the smaller print of the 2. The actual syringe went through a part of the CNC spindle holder, so the bottom support only had to be so large to hold up the entire length of the syringe. Some final test prints with the motor mount to account for the small raised part in the middle, and also a test part to see how it would end up connecting the top and bottom parts together, for both spacing and what screws I was going to use. After I felt confident in my measurements, I went ahead and printed the final top piece. Now, as it's printed overnight, I had an absolutely demonic view from my bed. The shadows moving with the red light really made it difficult for me to sleep without fear of being snatched by a creature not meant to be witnessed by mortals. I used a roll of flat duct tape to block the bright screen from shining right through my retinas, held in place with some painter's tape. Very, very professional. However, after this print, the project was practically almost done. I removed the custom supports, which were the 2 cylinders in the gap when I was cutting it, and mounted the bottom and top halves together with some screws, and added the motor on top as well. I didn't have any documentation the first time I did it, since it was getting close to the deadline of the trade fair and I just wanted to get everything working before it, but here's me assembling the full mount. As you can see, there's a bit of duct tape on this one weak part. This is when it was printing and it was near the top. I assume it wobbled a lot and therefore messed up the filament being laid down. You can see it getting progressively worse with each layer. This was fine structurally, but when I was testing, the screw wasn't cut properly, so the plunger's notch turned and ripped that rail clean off. I used a soldering iron to melt and repair the plastic, but ended up breaking again during the trade fair, so I duct taped it temporarily. And we all know what temporarily really means in engineering.
I heard about your temporary leave of absence, by the way. Those things do have a nasty habit of becoming permanent, though, don't they?
So, with the massive mount secured and the motor screwed in, I just needed to get the frosting to print. There was a problem in which the printer would move at 1/10 the distance it was supposed to, but I fixed this by changing some firmware. I did this using Marlin, an open source 3D printer firmware editor, and got the files for the Ender 3 board that I was using, and changed the default settings for the steps per millimeter of the board. What that does is simple. When moving 1 millimeter, the motor would use 10 times the amount of steps, thus moving 10 millimeters. Steps are the unit that servo motors use, commonly 1.8 degrees, and are the increment it moves in. By telling the board what it thought a millimeter was simply just wrong, and needed to move 10 times that amount, that fixed the problem entirely. So, after everything was printed and the board was running with my custom firmware, everything worked perfectly enough. There were a few unforeseen problems that I had to fix during the trade fair, but that was mitigated once again just by sending G-code to the printer. But what happened is that the board was told its center was on the cookie cake, since we reset the position each time we wanted to print. But it assumed the boundaries of where it could and could not go relative to that, a safety measure to stop the printhead from hitting the frame. So, when we wanted to print, given the board thought it was an Ender 3, the board thought it was near these perimeters and wouldn't move past them. However, this is mitigated just by telling the board that it could roam freely like the wind, in G-code, of course, which can then be permanently mitigated by changing the firmware. So, speaking of trade fair, after getting the machine fully operational and printing designs on cookies, we started collecting tokens, which are the poker chips that the investors give us if they like our product. I had a few notable guests that stopped by, one of which was my calculus teacher, who was also very into cooking. He noticed I was having problems with getting the chocolate frosting to print uniformly, since it was either getting stuck in the syringe or leaking out, and he told me that chocolate can seize up under pressure, and would need to be reset and rest before being pressed by the plunger again, which meant that the hardest part of this project and the worst thing to deal with ended up being the choice of frosting. We only needed this because A, chocolate, and B, we're only allowed to bring store-bought food, so any thinner frosting I could whip up myself would be illegal. Though, after letting the chocolate rest for some time, I was able to start printing fairly well again. Secondly, I had a couple come by, where one was a cake decorator and another was an engineer, which is the perfect audience for this project, or rather, product. Both of them saw the use for what I had done, and were both appreciative of my in-depth explanations. Given the potential value of the product, and the scalability to use multiple different colors, different frostings, tips, and really anything else that could be customized, they each gave me a token. This is a lot better than almost everybody else, where my group would pitch the product and show it working, only to find out they ran out of tickets an hour ago. I also had an administrator that came by and gave me tokens because I walked him through the design process so thoroughly that he decided this product deserved more than just a pat on the back. Although we had already run out of tokens, he went into the back and got some more for us, allegedly. He was amazed at the 3D printed parts, all the code that I showed him, and why detailed explanations once again. I've developed tutorials that teach people coding along with teaching people in person, and seeing their initial confusion has made me refine how I explain things so it can be a lot more clear, and that carries over into a lot of different things. Oh yeah, coding tutorials. This is a plug, check them out. So, what have I done since? Well, I 3D printed the second variant of the bottom mount, which is practically the same thing as before, but just without supports and an inch shorter. I also knew this because the original model broke when we were packing up for the trade fair. Given the time savings of not printing supports on the second variant, I also increased the infill significantly. Now the whole structure is a little lower profile and much stronger at the base. Also, I got a standing desk for Christmas. Which is why you see the plastic table in some clips get replaced with this nicer wood table. At my massive stature, the back pain when standing and bending over to work on a table can really hurt, so this is really a game changer. Overall, this project was not only fun to get a little messy with, but also taught me a lot about how computer-aided manufacturing works, as I now have experience customizing both a CNC machine and technically a 3D printer. This isn't the first project I've done, just the first that I'm posting here, since it's the only one I've heavily documented so far. I'm currently working on other projects and I started to document them too, so I'll upload those when I finish. But other than that, have a good night, y'all.